So writing out electron configurations, right, they can be really, really long, especially when you get into the elements that are higher in atomic number. So like the one we did for tin or the one that we did for strontium. So there's actually a shortcut method for writing electron configurations that won't make you go through all of the electron configurations for the lower level electrons. So what we do is something called noble gas core. So the electron configurations for the noble gases are known, right? So here's the noble gas, or the electron configuration for the noble gas helium is 1s2, neon is 1s2, 2s2, 2p6, argon is 1s2, 2s2, 2p6, 3s2, 3p6, so on and so forth. So we know the electron configurations for our noble gases, and the reason we choose the noble gases is they're all the way at the end of our periodic table. And the big deal with them is that they have a full S and a full P in their highest energy level. Okay, so if we look, the highest energy level for argon is N equals 3, and we can see that there's 2 electrons in its S and 6 electrons in its P. If we look at neon, for example, its highest energy is N equals 2. And we can see that its S and its P are full. So we choose noble gases because their highest energy shell is full. So what we're going to do with that is we're going to use the noble gases to shorten our electron configurations. And we can see that here. Okay, so here's the electron configuration for argon. Here's the electron configuration for iron. Okay. So we see this big, long configuration, but we can see that this configuration here for argon is the same as this chunk of the electron configuration for iron. So we can shorten that. So what we're going to do is, because these are the same, we can write a noble gas configuration for it. So we call this noble gas core, because the core of our electron configuration is the same as this noble gas, right? So the core of our electron configuration for iron is the same as argon, okay? And these are also what we call the core electrons. So we're going to talk a little bit more about atomic structure in terms of what are valence electrons, the outermost electrons, and what are the core, which are the innermost electrons. So the core electron configuration is the same for argon and iron. So what we can do is we can represent this entire chunk of the electron configuration by simply writing in square brackets, not parentheses, but square brackets, argon. So when we write square bracket AR and square bracket, what this means is 1s2, 2s2, 2p6, 3s2, 3p6. So this right here is representing this whole chunk of the electron configuration. So then all we have to do is go to the placement of where argon is on the periodic table and pick up from there. So we come back from argon, and the next thing we have is 4s2, and then 3d6 is where we find iron. So the electron noble gas core notation is going to be argon, 4s2, 3d6 for iron. And that's a lot shorter and nicer to write than this whole long electron configuration. The AP exam will tell you which method to use. Sometimes the AP exam will want you to write the full electron configuration. They just want to see, do you know how to write everything for the core? Sometimes they'll say that it's totally fine to write the noble gas core formation. Okay. On your problem set 5, you guys are going to practice both, writing the full. So when it says full, you're going to write the whole thing. When it says noble gas core, you're going to substitute the core electrons with one of the noble gases. So if I take a look here, we're going to do our electron configurations for these, but we're going to shorten it up, okay? So I'm going to find copper. So that's my first one, Cu is copper. Copper is right here. So what I do is I follow my element back to where the closest noble gas is on that periodic table. So here is copper, I follow it back, and the closest noble gas is argon. So what I'm going to do is square bracket Ar for argon, and then I'm going to pick up the electron configuration where argon left off. So I'm going to come over here, and that's 1, 2, 3, 4. So that's going to be 4s2, And then I'm going to come along here, and I've got, so this is, remember, D block starts at 3 because it doesn't show up to the 3rd energy level. So 3D, and I'm going to count those over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so argon is going to be 4s2, 3d9. Okay, cool. So now we're going to do cobalt. So I'm going to look for cobalt. Cobalt is CO, and cobalt is right here. So cobalt, follow it back to find its noble gas, and it's argon again. So we're going to put argon, AR, pick up where argon left off. So we've got 1, 2, 3, 4s2. And then we're going to come across 1, 2, 3, 4, 5, 6, 7. So 3d7. Okay. Now we're going to do calcium. So calcium is right here. So there's calcium. So I'm going to follow this back to my next noble gas, and again, it's argon. So I'm going to write argon. And then I'm going to follow it forward and complete it. So 1, 2, 3, 4. So that's 4s, 1, 2. So that's all we have to write there. So now I'm going to do carbon. Carbon is right here. I'm going to follow this back to its noble gas, and its noble gas happens to be helium. So in parentheses, or square brackets, I'm going to write helium, He. And I'm going to pick up that noble gas, or pick up the configuration from the noble gas. So here's helium. So then I've got 2s2. And I'm going to come across to carbon, and carbon is in 2p, and that's 1, 2. So there is our configuration with the noble gas core. Argon, ironically, you cannot just necessarily write parentheses argon. So what we're going to do is we're going to go back, and the noble gas for argon is neon. We're going to pick up where neon left off. So here's neon right here. We're going to come around from neon, and we're going to pick up at 3s2. Come across here. This is 3p, 1, 2, 3, 4, 5, 6. So 3p6. And then the last one we're going to do is gallium. And let me make sure it's all blurry. There's gallium and germanium right next to each other. So this one is gallium. So I'm going to go back, and hey, look, it's argon again. I swear you can use other noble gases besides argon. Your problem set will get you to use other ones than argon. So here's argon, and it's going to be 1, 2, 3, 4. So 4s2. Come across, that's 3d10. And then we've got right here for gallium, this is 1, 2, 3, 4p. And it's only 1 over, so it's 4p1. Okay, so that's how you can do your electron configurations using noble gas core. So yeah.